so now we're going to be adding and subtracting rational expressions. So let's just start with a nice straightforward fraction so we can remember how we do this. If I'm adding 2/3, let's say, plus 1/2. Okay, I cannot add those as is because those are two different size pieces, right? This is as if I had cut my pizza into thirds, and I have 2 of them. This is telling me I cut my pizza into halves, and I have half of it. Remember, the bottom number tells you the size of your piece. It tells you how many pieces you've cut your whole into. So I cannot add those because those are like adding apples and oranges. They're two different size pieces. What I want to do is I want the size of the piece, in other words the denominator, to be the same. And then and only then can you simplify by adding. Okay? So you need to get a common denominator. Whenever you're adding and subtracting fractions, and this will go for rational expressions too, you need a common denominator. The bottom number needs to be exactly the same because that tells you how big your piece is. So let's do this one. I want to look for a number that both 3 and 2 will multiply nicely into. And I'm thinking 6 will work. I can turn this into 6ths and that into 6ths. Alright? So I can visually do that, of course. I can turn both of these into 6ths. So I just cut my pie into 6ths. The way I do it using arithmetic here is I say, okay, how do I turn a 3 into a 6? Oh, I multiply that by 2. Whatever you do to the denominator, of course, you have to do to the numerator so that you don't change the value of the fraction. I'm just multiplying by a fancy form of 1. Right? 4/6 is the same amount of pi as 2/3. Right? So let's look here. How do I turn a 2 into a 6? Oh, I multiply it by 3. Whatever you do to the denominator, you do to the numerator. 3/6, I think you'll agree, is it's exactly the same as 1/2. Right? You have half a piece of pie. Half of a pie is the same as 3/6 of a pie. Okay, now you have the denominators the same, so I can go ahead and add up how many pieces I have. I have 7 pieces, and they are 6ths. So I have 7/6. So, common denominators, that's what it's all about. That's what it's all about. Hey, let's do that with some rational expressions, shall we? Okay, so here I go. Actually, let me do that over here. I'm still going to want to get a common denominator. Let me give you one that starts with a common denominator. So let's simplify. Let's just say 7 over x plus 1 minus 3 over x plus 1. Well, that's not that bad. I have a common denominator, so all I need to do is to say, oh, that's 7 minus 3, which is 4. And you're done. That's it. Nice and easy, right? All right, what if I had, let's get a little more complicated, 2x plus 5 over x minus 7 plus x minus 1 over x minus 7. Okay, I want to simplify these. I want to combine them. I first look to see if I have a common denominator, and I do, so I'm so far so good. All I want to do now is combine my numerator. I'm just going to write it out. You don't need to write it out, but I'm just going to do it so you see what I'm doing. Now it's just a matter of combining like terms. 2x goes nicely with that 1x to give me a 3x. 5 minus 1 would be a 4. And then I have x minus 7. Now when you're done, you always want to make sure you can't go any further, right? By going further, I mean, can I do any simplifying? Now keep in mind, I have addition and subtraction, so I can't do any simplifying, meaning dividing, unless I can factor. So I'm not thinking either one of these look factorable. So I am done. I have fully simplified this. Let's do a subtraction, because subtraction can get a little sticky. What if I had something like 2x plus 6 over x plus 1 minus, there's the subtraction, let's say 5x minus 3 all over x plus 1. Okay, so we still have a common denominator. So here I go. I can just combine those numerators since I already have a common denominator. I'm just going to write it out again, 2x plus 6. Okay, now comes the sneaky part. I'm subtracting 5x, and I'm also subtracting a negative 3. Subtracting a negative 3. There is my two negatives making a positive situation, right? You can think about distributing that subtraction, if you will. So that is the sneaky part with subtraction. You have to make sure you distribute that negative. And then we just combine like terms. Let's see, 2x minus 5x, that's our negative 3x. 6 plus 3 is a plus 3 over x plus 1. Okay. Now, this is an interesting situation. Am I done? Is there anything that I can do to simplify this? Now, some of you guys at home might be thinking, wait a minute, I think I could factor out a 3. I think I could factor out a 3 if I wanted to, right? And I would say, whoops-a-daisy. And I would say, yes, you could factor out a 3, or a negative 3 if you wanted to. But does that lead you to help you simplify anything? Does that help you to do any dividing? It doesn't. So there's really no need to do any factoring. You are done because even though you can factor, it does not allow you to do any dividing. That was a little tricky. Does that make sense? Let's look at one where you could do some simplifying. Let's say I have x squared over x plus 6 plus 6x over x plus 6. All right, same denominator, so I'm just going to combine my numerators. That's not too bad so far. So I have x squared plus 6x. Am I done? No, I am not, because I can factor. Now, you might be tempted to say, oh, I can do some dividing here, but you can't do that because, of course, we have addition. We have addition. You cannot undo addition with division. The other way to think about that is I have two terms on the top and two terms on the bottom, and they're not exactly alike. So I cannot do any dividing unless I can factor. And I can factor. Can I factor out a GCF? What, those two terms both have an x in common, so I'm going to factor out an x. That leaves me with an x plus 6. Ooh, this is looking very hopeful. Hey, by factoring now I have things multiplied. I have a blob of things multiplied in the numerator, which means I can do some dividing. X plus 6 is exactly identical to x plus 6. That leaves me with 1 x over 1, which is the same as x. Can't get much simpler than that. Let's do one where you actually have to get a common denominator. And then I think you'll be in good shape. Let's say I had something like 5 over 2x minus 7 over 3y. Okay. I do not have a common denominator, so I'm going to have to figure out what a good common denominator would be. So I want that common denominator to be something that a 2 can go into, and an x can go into, and a 3, and a y. So let's look at those numbers first. 2 and 3, I'm thinking 6. How about you? Right? I think 6 will work. Now, I need an x in my denominator, because there's an x here. I need a y in my denominator, because there's a y there. So I think 6xy will make a very nice common denominator. So now I look and see, well, how do I turn a 2x into a 6xy? Well, I have to multiply that by a 3 and by a y. Whatever you do to the bottom, you do to the top. 3y times 5 is 15y. All right, what do I do to this to turn it into a 6xy? Well, let's see, I want to multiply by 2 and x. Whatever I do to the denominator, I do to the top. 14x. Okay, now that I have a common denominator, I can just subtract. Those are not like terms, so I'm just going to write it like that. Now, always ask yourself, can I do any factoring that will lead to some simplifying? And looking at those two terms, I don't see anything they have in common. It's certainly not dots, it's not a trinomial, there's no GCF. So I'm done. That is fully simplified. Now if you'll notice, what I ended up doing here to get a common denominator is I just multiplied the two denominators together. That will always work. And in some situations, it's the best way to go. But not in all. Look at this. Let's say I had a x plus 1 over 3x squared plus a, let's see, an 8 over 3x. All right, do those have a common denominator? Not quite. They're very close. This guy has a 3 times x times x. This is just a 3 times x. Now in this case, I don't want to get a complicated common denominator and multiply them together. I think I can just tweak this one over here. What does this not have that this has? It needs another x. So I can actually use this as my common denominator and just change this fraction. So this guy needs another x to turn it into 3x squared. So if I'm multiplying the denominator by x, I'm going to multiply the numerator by x, and that is my equivalent fraction. This guy didn't change, which is just fine, because I have a common denominator. So let's go ahead. 3x squared. Let's see, I have an x plus 1 plus 8x. That x and that 8x give me a nice 9x plus 1. Is there anything I can divide? No, there is not. I can't do any dividing because I've got two terms up here. There's nothing I can factor, so I am fully simplified. All right, I hope this was helpful.